Won't be leaving this block anymore today. We are on lesson 1, 2. No, I'm sorry, it's 3. 1, 3. And it begins on page 14. Because you're looking at a picture doesn't mean you have to start talking. Page 14. In Finland, people sit for a short time in sauna houses that are heated up to temperatures as high as 120 degrees Fahrenheit. Then they go outside where the temperature may be as low as negative 20 degrees Fahrenheit to cool off. The two thermometers shown are similar to vertical number lines. On a thermometer, a move down shows a decrease in value. The temperature gets colder. A move up shows an increase in value. The temperature gets hotter. One horizontal number line can show the same information as the two thermometers. They show you that one horizontal number line on page 14 at the bottom. Look at that number line now and think for a minute, what does n represent? What does the variable n represent? It doesn't want an answer. It doesn't want a number answer. What does that number, if you were to get an answer, what does that tell you? Gage.
Negative.
No. It doesn't want an answer of any kind. It wants to know what it's telling you. What does the answer tell you, John?
That's the middle of the...
No, the n is the whole thing. The whole thing that's highlighted. Jerry. No, it tells you how cold and how hot it is from where it started and where it ended. The variable n is the change in temperature. How much did it change? When it went from 120 down to negative 20, n represents that amount. How much did that temperature change? Look on page 15. On a number line, a move to the left is a move in a negative direction. The numbers decrease in value. A move to the right is a move in the positive direction, and the numbers increase in value. The National Weather Service keeps records of temperature changes. The world record for the fastest rise in outside air temperature occurred in Spearfish, South Dakota on January the 22nd, 1943. The temperature rose from negative 4 degrees Fahrenheit to 45 degrees Fahrenheit in 2 minutes. I know, right? Crazy. What was the temperature change over those 2 minutes? 96. Now it went from negative 4 to 0, and then from 0 to 45. How many times has that been moved? Negative 4 is 4 points up to 0, and then from there, 45 more up. 45 plus 4 is 49. It was a move up 49 degrees. So that was a positive 49 degree move. From negative 4 degrees Fahrenheit to 0 degrees Fahrenheit is a change of positive 4 degrees. From 0 to 45 is a change in 45 degrees. So the total change is a positive 49 degrees Fahrenheit. And you can see there on the page on 15, they've written 2 number sentences. So today what we're going to do is we're going to be using number lines and number sentences in order to solve the problems that they're asking us to solve in 1.3. Before we begin, Gage, Putoff were in the building. I would like you to switch places with Tyler. Page 16 begins our problem. Now, before we go into using a number line and number sentences, we're working with addition of integers today. Have I had you write down the adding rules yet? No. So, the first thing we're going to do is write down those rules. You're going to get a flow chart with all 4 operations on it tomorrow, with adding, subtracting, multiplying, and dividing. But today, we're going to need the addition one. We're going to work with it quite a bit, so I want you to write these rules down in your notebook. So whenever you find out what operation it is that you're doing, you'll just choose that operation along your flow chart, and then it will ask you a question. Are the signs the same? Or different? And when you answer that question, you're answering it in one of 2 ways. It's either the same and you take this branch, or it's different and you take that branch. Now, we're using number lines today so that you can see why the rule actually works. When we use chips tomorrow, integer chips, it's only so you can see why the rules actually work. Not that you're going to be using number lines or integer chips or even heap and holes when I show you the heap and hole model. Because on that first problem that we just looked at, we were up here at 115 degrees. And they get out of that sauna and into negative 30, negative 20 degree weather. We're not going to use 150 positive chips. One, I don't have that many. You're not going to want to take the EOG and sit there and draw 150 circles on your scratch paper. We're only using these other strategies as we go so that it shows you why the rule works. And then you should start to move over to using these rules. Now again, we're only going to look at the addition ones today, and even tomorrow, because we'll be adding with the integer chips. But these are what you want to memorize, and these are what you want to get used to using. So if they're the same, it will tell you to add. If they're different, it will tell you to subtract. Once you've done those 2 things, you've got the answer. Now you just have to apply a sign to the answer. So then from there, you will give the same sign to the answer. After you subtract and get your answer, the way that you get the sign for that answer is the bigger number gives the answer its sign. Now again, tomorrow I'm going to give you a flow chart that's got all 4 operations on it. But because we're going to be using these today, you need these in front of you so that you can go ahead and start using them, start memorizing them. So A, now the directions ask us to use a number line and number sentences to answer all of these. So that's what we're going to do. A person goes from a sauna at 115 degrees to an outside temperature of negative 30 degrees. What is the change in temperature? Okay, I've already written it on the board, the number line. We were in a sauna at a positive 15 degrees, and then we go out into negative 30 degrees. So when we go from positive 115 to 0, how many points have we moved? 115 points. But then we go from 0 down 30 more. So how many total points have we moved? 145 points. So that was a 145 degree drop. So we're going to express it as negative 145 because we went down 145 degrees from 115 to negative 30 to 30 degrees below 0. Now our number sentence would have been very similar to what the number sentence on the front that we just read through. It had, we started at 115, then the change was in number of points to end at negative 30 degrees. So how would you find the answer to end?
15.
And that is this answer that we just got. But we use the number line to get it. We haven't solved one-step equations. Some of you were introduced to one-step equations in 6th grade. But that would be the number sentence that we would need for this one. So it would be, I'm at 115, it changed this much, and I ended up at a negative 30. What was done to end? We've added 115. What's the opposite of add?
Subtract.
So we're going to subtract 115 from both sides. Remember, it is a equation, and an equation, what you do to one side, you have to do to the other. So that leaves n by itself, and we're going to get good at doing subtraction. Most of what we do today is not going to be subtraction, even when we set up our problems. But it's the same as adding the opposite when you subtract. So you have to change all your subtractions back to addition. So now that we've got an addition and now you know the rules to addition, are the signs the same or different?
Same.
The same. What does it tell you to do when they're the same?
Add.
Add. 115 plus 30 is 145. And then you give that same sign to the answer. So that's where we got our negative 145 from. Because it was a 145 degree change from 115 to 30, but it was a change downward, so it was negative. John?
When you get like majorly sick, you know?
I would think so, but people in Finland do it all the time, so I guess it's what you're used to.
I've seen what people do.
I don't know.
But I know after I always took a shower and my head was wet, my grandma would say, "You don't go outside." So I don't know. It's just what you're raised with and what you're used to. I'm sure some people could get deathly sick from it. B, the temperature reading on a thermometer. So right now you're going to stop and you're going to draw a thermometer. (25 degrees). During the afternoon, the temperature changes. What is the new reading for each temperature change? Now, this is what 1, 2, and 3 is asking you to do. Each one of them, we start at positive 25, at 25 degrees above 0. Number 1 says you rise 10 degrees. Then you go up 10 degrees. Where does that leave you?
25.
I'm not asking you to answer it. I'm just telling you what each one of them are asking you to do. So then for number 2, it says, and then I fall 2 degrees. Where does that leave you? Then the next one is saying, then you fall 30 degrees. Where does that leave you? So these are our number sentences for 1, 2, and 3. And of course we've got our number line here that's going to help us too. So, if I start at 25 and I go up 10 points, where am I at?
35.
25 plus 10? 35 degrees. Now, I'm going in the same direction. 25 positive, 10 more positive, puts me at positive 35. That's why if the signs are the same, you add, because you're going in the same direction. So I would add this 25 to that 10 to get that 35. So it's a positive 35 is the first answer. Any questions on how we got that? Jerry.
So all you have to do is just add the
If the signs are the same, you add. Yes. Nope. If they're different, what does your flow chart tell you to do? You subtract. So now if I'm back at positive 25, and then I go down 2 points, 24, 23, I'm at positive 23. Now, the signs are different, so I subtract. 25 minus 2 is 23. The bigger number is 25. That sign is positive, so it's a positive 23. So you're using your rules to check yourself. I start back at 25. I go down 30. Now, I know I've gone down 25 to get me to 0. How many more do I have to go down?
5.
5 more, which puts me at a negative 5. So that's where I should be. So now let's use our rule and see. The signs are different, so I subtract. 30 minus 25 is 5. The higher number is negative, so it's negative 5. Any questions about how we got those answers? Now again, it's asking us to use the number line and use number sentences. That's what the strategy is today. That is going to help us get to the numbers that are our answers. Any questions about these before I erase B? Jerry?
So, since you have 25 and you have negative 2, you basically subtract 2.
Because you went down. Remember, negative is a downward movement on a thermometer.
And then the positive on 25, you just added to that.
Because the bigger number was positive, and that, so you're still going to be in the positive realm because there were more points in the positive than you were in the negative.
Right.
So that's why you give that number sign to the answer. See? C's asking you something a little bit different. The temperature now on the thermometer is negative 15. What is the new reading for each temperature change? Now, the only difference here is it's using signs instead of words to tell you which direction to move on the thermometer. It's the same thing as what we just did, except it's using the positive and negative sign to tell you which way to move. So go ahead and put your thermometer on your page, because again, our strategies today are using the number line and doing number sentences. So C says if our temperature reading is at negative 15, and then we have a positive 3 temperature change, we have a negative 10 temperature change, and we have a positive 40 temperature change, then where will we be at the end of those? Now, if we're at negative 15 and we went up 3, 14, 13, 12, we would be at a negative 12. Negative 12. Are the signs the same or different? Different. So you subtract. 15 minus 3 is 12. The higher one is negative, so it's negative 12. We're at negative 15, and we go down, and we go down 10 points from 15. Negative 25. Are the signs the same or different? The same, so you add 15 plus 10 is 25, and they're the same negative, so it's negative 25. Now we're at negative 15 again. This time we go up 40 points. If I go 15 to get to 0, how many more times do I have to go to move 40 times? 40 minus 15 is 25. So now I'm back up to a positive 25. Are the signs the same or different? Different. Different. So you subtract. 40 minus 15 is 25. The higher number is positive, so it's a positive 25. What is the change in temperature when the thermometer reading moves from the first temperature to the second temperature? It moves from the first temperature to the second temperature. So they're wanting the change in temperature. Now this one is a little different. I'm going to draw a thermometer this time that goes from negative 20 to positive 20. And then we're going to write the number sentences exactly what are they asking us to do. So you're drawing a thermometer, and I am numbering mine every 2 to 20. I'm not going to come to your seat and draw it for you. Draw a thermometer. You may choose to do it every 5. It's just whatever floats your boat. I wanted to do it every 20. So here's what it's asking you to do as far as our number sentences go. I start at positive 20. Then I move this much and I end up at negative 10. Number 2, I'm at negative 20, then I move this much, and I'm at negative 10. 3, I'm at negative 20, then I move this much, and I end up at positive 10. Number 4, I'm at negative 10, then I move this much, and I end up at negative 20. Number 5, I'm at positive 20, I move this much, and I'm at positive 10. And then the easiest one, I'm at positive 10, I move this much, and I'm at positive 20. So this is what it's asking you to do for D. Now, if we knew how to solve equations, we could go ahead and plug n into all those blanks and solve for n. But if we don't, and we know that it's just an adding of positive and negative numbers, then we draw our number line and then use the number line to solve the problem. So this is how we're going to use the number line. I start at positive 20. Here's my start point. I want to end up at negative 10. Here's my stop point. So going from here to here, that's a positive or negative move?
Negative.
Negative. So this number is going to be negative because it's a drop. It's a drop of 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 24, 26, 28, 30 points. So this is a negative 30. And how do I know if I'm right? Use the rule. Are the signs the same or different?
Different.
Different. So you subtract. 30 minus 20 is 10. The larger number is negative, so it's negative 10. So I would be right. And I have my number line, my vertical number line on my thermometer, so that I can find that answer if I didn't know how to do one-step equations and substitute that line for n. Now I'm at negative 20, which is down here. I want to go to negative 10, which is here. It's an upward move. So what is my sign here? Positive. And I have to go upward 2, 4, 6, 8, 10 times. I've got to go up 10 times. So now the way that I would know if my number line worked for me is to try my rule. Are the signs the same or different?
Different.
Different. So I subtract. 20 minus 10 is 10. The higher number is negative, so it's a negative 10. So that worked. For the next one, I start at negative 20. Here's my negative 20. I'm going to positive 10 this time, which is up here. It's an upward move. So what is this?
Positive.
Positive. How many upward?
30.
2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 24, 26, 28, 30. It's this one backwards. So when I get that answer, then I check myself. Are the signs the same or different?
Different.
Different. So I subtract. 30 minus 20 is 10. The higher one is positive, so it's positive 10. You use your number line and do these three for me on your own. Use your number line. Move on it like we were just doing from 1 through 3. We're going to do these together, but I want you to try it on your own before we do. Where do you start? Where do you end? Which direction move is it? How many points do you move? Those are the questions you're asking yourself. For 4, we start at a -10. It's down here. We want to go to -20. It's down here. It's a downward move, so this is a negative. It's a downward move of 2, 4, 6, 8, 10. Are the signs the same or different? The same, so you add 10 plus 10 is 20, and you give that same sign to the answer, so it's -20. +20 is up here. We want to go to +10, which is here. It is a negative move. It's a negative move of 2, 4, 6, 8, 10. Are the signs the same or different? Different. We subtract. 20 minus 10 is 10. The higher number is positive, so it's a +10. And I hope you know that 10 plus 10 is 20. But 10 is here. We want to go to 20, which is here. It's an upward move. It's an upward move of 2, 4, 6, 8, 10 points. The signs are the same, so we add, and 10 plus 10 is 20, and that same positive sign goes to the 20, so it's a +20. Any questions about D? Again, using a number line and using number sentences in order to get us where we need to be. Yes. Be careful going by the camera. Let's look at E. And I will let you know, this calculator that we're using, there is a negative button on it. It's underneath the number 3. So if there's a calculator at your desk, go ahead and look at that real quick. If it's a calculator active problem, you have to punch in the number first and then apply the sign to it. So you can't punch in -3. You punch in a 3, then you make it negative. So there are certain keystrokes you have to do. But there is a negative sign there, and that's what that button under the 3 does, is it changes the signs of your numbers so that you can use your calculator to compute with positive and negative numbers. And you will get some chances to use your calculator to solve those kinds of problems, but for now, we're using numbers that are small enough that just using the models that we're going through right now should be sufficient. Jerry, quickly. Just look at this one so you don't have to get up and move. The temperature was -5 when Sally went to school on Monday. So that's where we begin, and that's the first number that she writes. The temperature rose 20 degrees. Then it moved in the positive direction 20 times. That's what that's saying during the day. But then it fell. Which direction is that?
Negative.
Negative. It fell 25 degrees during the night. A heat wave increased Which direction is that?
Up.
Up. Increased the temperature 40 degrees
30.
on Thursday. But then an Arctic wind overnight, then it decreased 70 degrees Fahrenheit. And when you see the answer to this, you will know why that exclamation point is there. Speaking of Arctic air, we get an Arctic blast tonight, so tomorrow it's not even getting out of the 30s. So it will be significantly colder tomorrow and Friday compared to what it has been. And they're even talking about ice Friday night, but you're already out for Christmas break by then, so don't get so excited. So, but we are going to work this. This is order of operation because it's nothing but addition, and you know when you have just addition and subtraction, you move from left to right. Tyler?
I believe these people are sick.
They should all be, unless they're used to it.
I'll be quick.
Okay, we're going to start. Excuse me. I'm going to wait for you. We're going to start by just doing these two. Now we're going to follow the rules. I'm going to ask you the questions. Be ready to answer. Are the signs the same or different?
Different.
So we subtract. 20 minus 5 is?
15.
15. The higher number is positive, so it is positive 15. So now I'm going to drop the next one. These are the two we're focusing on. Are the signs the same or different?
Different.
Different. So we subtract. 25 minus 15 is? 10. The higher one is negative, so it is?
Negative 10.
Negative 10. Lord, by the end of that night, they still ain't out of the negative. It is cold in that place. So we're going to drop the next one. Are the signs the same or different? Different. We subtract. 40 minus 10 is?
30.
30. That's still below freezing. The higher number is positive, so it's positive 30. Then we're going to drop this one. Are the signs the same or different? Different. So we subtract. 70 minus 30 is? 40. The higher number is negative, so it is? Negative 40 degrees.
It is, I am not moving
40 degrees below zero.
I know, right?
You might would freeze then.
Yeah, I wouldn't come to school.
I'd have like
Wait, you would?
Negative 40 degrees.
I
don't think my car would start at negative 40 degrees. Do y'all know that there are places, well, some of you have traveled, but there are places where you go that when you park at Walmart, there is a warmer in the parking spot to keep your block from freezing.
Oh,
That sounds like Alaska.
I mean, it's up north. Like I know
Canada?
Missouri has it, and I've never been far up north when it's been cold enough that I'd actually see that. But they have places in the parking lot that you park over to keep your car from freezing, where it will start when you come out.
That is
So
probably-
I'm sure at negative 40, something in there's going to freeze.
I'm pretty sure like
I don't want to see negative 40.
That's Canadian weather.
That's I'm moving to Florida kind of temperature right there.
Yeah.
So E number 2.
Chicago's like that. They wouldn't like it.
I'm waiting for you.
They wouldn't.
E number 2. Sally's work for finding Monday's temperature changes in part 1 is shown below. The temperature changes. Do you agree with Sally's computation? And explain your reasoning. Now, we're going back to number 1 because it says changes in part 1. And we're just looking at Monday. So it said we started at a negative 5 when she went to school. Then the temperature rose 20 points. And then it fell 25. Now, if we were going to solve that, and we just did, we said that this left us at a positive 15, and then these two, when we done it, left us at a negative 10. She got a negative 10, but what she did was, when she was at this point, notice the one underneath it. She said that 15 subtract 25 left her at a negative 10.
No, that would be,
Is that true?
that'd be like positive 40. Yay.
Is this still true? We know this is, we just solved it.
Probably.
But is this
Yeah.
true?
Yes.
Oh, no, I'm thinking
Now,
I'm thinking about it.
it's an unfair question because we haven't learned subtracting integers. I feel like yesterday was kind of unfair when they wanted you to solve an inequality and we haven't solved inequalities. So I think that the program is bringing some things in just to introduce it to you or front load the material so that when we do get to it, it doesn't look Greek, that you have heard some of it. We've already done one of these. I told you it was the same kind of rules as whenever you're dividing fractions. You keep the first one the same. You change the operation sign, but then you had to change. It's a keep, change, change kind of thing. So it looks exactly like this now, doesn't it? When I change the subtraction to addition and I followed those subtraction rules, it changed it to be the very same problem that we just solved. So even though she wrote it differently, she is still correct. Because we change all subtraction to addition. It's the same as adding the inverse or adding the opposite when you are subtracting integers. It is the same as adding the opposite. Gage. Quickly. Any questions about E2? This is the last one, but I'm fixing to put you some practice up on the board. Any questions?